Hey guys, I'm Mrs. Delavecchia, and before we start, I want to remind you to take notes using the guided notes that are in your unit packet. Those notes will be a part of your grade. If you have any questions, write them down and we'll go over them in class. So let's get started. All right, so today we're going to look at a little bit about linear measure and what all that means. We're talking about how we use linear measure, what it means to be congruent, and then we'll look at the segment addition postulate. So linear measure is quite simply the measurement of something that's in a straight line. So I think if I wanted to measure my table and see how long it is, I'd measure the straight distance down the table and I would get that measure. It's a length, so it's never going to be a negative number. So here, even on my number line, the linear measure from -3 up to +3, right? I'm going to go 1, 2, 3, 4, 5, 6 places. So it is a +6 would be the linear measure from -3 to 3. Right here, if we have two linear measures and they are the same, then we can say that those things are congruent. So congruency means they are equal in their measure. So for example, let's take a look at these two. We have segment EF. Okay, it's 2 units long. GH is also 2 units long. They are not equal. They are not the same thing. One goes from -6 to -4. The other goes from -1 to 1. But they are both, their measure is 2, and therefore we can say that they are congruent because they have the same measure. Notice this indicator for congruency. It's a squiggly line on top of an equal. So kind of think of it as, you know, it's almost equal, but not quite. It's just congruent because it's only equal in measure. All right, so let's check these. We go from -5 to -2, that's 3. And from 3 to 5, that is 2. So we would say these are not, BA is not congruent to ND. All right, AB congruent to CD, yes. These are both 10 and 10. They are different segments, but they are equal in measure, so we can say they're congruent. Another thing I want you to notice is here the indicator for congruency. If you see just a single slash in a picture, that means those two segments are congruent. So GH is congruent to EF. And then over here, I've got 2 and 2 slashes. Well, that's just in the same picture. If you have another set of things that's congruent, not everything, all 4 of these aren't congruent to each other, so we wouldn't want to do another single slash. But so you add a second slash for, you know, for the 2 things that are congruent. If there was a third thing, you would put 3 slashes and continue like that. Okay, so that's how we note congruency. Segment addition postulate. First of all, a postulate is just something in math that we know to be true that we don't have to prove. We accept it to be true. So this postulate is saying that if I have segment AB and I add that to segment BC, then when you add those together, you would get the measure of AC. So that should be pretty straightforward, and you can see why that's a postulate. We don't, you know, we don't really have to prove that, but that is segment addition. So here, if we wanted to know the length from A to D, we would simply add up 8 plus 2 plus another 8. And the total would be 18. So we could say that AD is 18 units long. Okay, here's a written example. We have a line A, B, C. I'm going to encourage you to always draw a picture when you have problems in geometry. Point B is between points A and C. Find AC if AB is 16. And BC is 12. Now, it's a pretty straightforward problem. You may not have needed a picture, but it's a good practice to get into. So adding those together, you've got 28. Here's another one. The whole total distance is 32. So what is TU? So I could write a little equation, right? I could say that TU plus 20 is equal to the total, 32. And solving that, subtracting 20 from both sides, I would say that TU is equal to 12. Okay. Here's another one where we threw in some extra stuff. We have the total of DG is 60 feet. So again, I could write the equation that says DO plus OG equals the total, which is 60. So let's go ahead and do that. We'll turn this into an equation. 4x minus 3 plus 2x plus 21 equals the total 60. Now we just have to do what we've practiced recently. We're going to combine like terms. So I have an x here and an x here, so that's going to become 6x. I have a minus 3 and a plus 21 on the same side. So 21 minus 3 basically is 18 equals 60. All right, now I'm going to solve this equation. I'm going to look to get my variable by itself. So this becomes 50, 42, and then 6 times x. So I'm going to divide each side by 6. And I'm going to have x equals 42 divided by 6. 6 times 7 is 42. So x equals 7. Now, this happens over and over and over again in geometry. The question is solve for DO. So your answer is not x equals 7. Your answer needs to be what is the length of DO. Well, the DO is 4x minus 3. So now we know what x is. So DO equals 4 times x minus 3. DO equals 28 minus 3. So DO equals 25. Okay, so be careful. These kind of problems happen all the time where you feel like you're done because you found the value for x, but you're really not. You have to substitute it back in to get the actual value. All right, so we've learned about linear measure, that it's always going to be a positive number, and that congruent means to be equal in measure. We indicate congruency with this marker, or if we're in a picture, we would put slashes. And then we looked at what segment addition is. All right, that's it. Y'all have a great day. We'll see you in class.